we are going to discuss about a very important topic, which is nucleophilic substitution reaction. Nucleophilic substitution reaction in haloalkanes. Okay, nucleophilic substitution reaction in haloalkanes. So to discuss about this topic, we should know about first that what is the nucleophile. What is the nucleophile? So nucleophile is the chemical species which have a negative charge, okay, which have negative charge and electron rich chemical species, okay. And second, we should know about the nature, okay, nature of the carbon, okay, nature of the carbon, as like primary carbon, secondary carbon and tertiary carbon, okay, tertiary carbon. So what is mainly happen in case of the nucleophilic substitution reaction? As we know that what is the mean of the substitution reaction? Substitution means one displaces the other, okay. But the reason behind this, substitution or displacement, is that one only can displace the other if those species are more reactive than the species present in the previous compound, okay. Like if we talk about the haloalkanes, then the CX bond play a major role in the reaction, okay. If we talk about the CX bond, as we know that X is a halogen, and halogen is more electronegative. Halogen is more electronegative than the carbon. So due to the more electric nature, X attract the shared pair of electron toward itself more, so it partially get negative and carbon get partially positive, okay. So the partial nature of the carbon attract the another nucleophile like NU to attract on them, to attack on them, okay. So the formation of the partial positive charge on the carbon invite the nucleophile to attack on them, but this nucleophile only in the case of displaces the X when this nucleophile have higher reactivity than the X. Is that clear? Okay. Now we talk about the deep in the nucleophilic substitution reaction. Like R मतलब alkyl मतलब radical, okay. Alkyl group attached with the X, react with nucleophile, then it produces RNU, okay, RNU and plus X minus, okay, okay. Is that clear? Okay. So this is the basic of the nucleophilic substitution reaction. Nucleophilic substitution reaction can be happen in any chemical reaction, but especially we are talking about the haloalkanes because haloalkanes belong to the class 12 topic and very important compound, okay. And this is the property of the haloalkanes, okay. Okay, so this is the basic reaction. This was the basic reaction, and next if we talk about the specific compound like RX plus KOH. KOH means potassium hydroxide in the aqueous condition, okay. In which condition? In the aqueous condition. When react, then it form KROH plus KX, okay. So in the reaction of RX, when KOH in the aqueous medium react with RX, then it displaces the X by OH and ROH get the formation of ROH plus आपका KX. Okay, so in the case of KOH, OH is the nucleophile. Okay, OH is the nucleophile, which is the more reactive than the X. So due to this reason, OH can displaces the X from there. Okay. Uh, it is well known fact that X is very less reactive. X is very less reactive. Due to this reason, X can be displaced by any type of nucleophile, like your OH, like your CN, like your OCH3, or etc. Many molecules. Okay, many molecules can be displaces the X. Okay, because X have lower reactivity, and this is performed as lower nucleophilic substitution. Okay. Okay, if we talk about specialized compound like CH3 Br, okay, plus KOH, we can take here NaOH also, silver hydroxide also. Okay, but silver hydroxide when we take, then silver hydroxide perform the reaction in the moist condition, not the aqueous condition. Okay, be careful about this. Okay, so CH3OH plus KBr. Okay, so this is the displacement, and when methyl bromide or bromomethane react with potassium hydroxide, then it form the methanol. Okay, so methanol is the substitution product and the bromomethane is the reactant. Okay, so this is the chemical reaction. Okay, this chemical reaction can also be performed with a secondary carbon. Like secondary carbon, what is the secondary carbon? If the carbon connected with the two different carbon, then it is called the secondary carbon. Like this is called secondary carbon. And secondary carbon when react with the KOH, then it also perform the same reaction, and CH3 CH and OH plus KBr. Okay, KBr. Okay, so this is the reaction. Is isopropyl bromide isopropyl bromide and isopropyl bromide कह सकते हो, या फिर what can be the reaction, what can be the name of this compound? 2 bromo propane. Okay, 2 bromo propane. Okay, so this is the reaction. This is the primary carbon, this is the secondary carbon. Now we see the reaction of the tertiary carbon. Okay, tertiary carbon means a carbon connected with three other carbons. Okay, when carbon connected with three other carbon, then it is called what? Tertiary carbon. Okay, this carbon is called the tertiary carbon. So Br plus KOH in the aqueous medium as like that. So this is give the formation of CH3 and CH3 and OH plus KBr. Okay, so this is the basic reaction. Okay, so this is the basic reaction, and this is the primary and this is the tertiary. Okay, this is the primary and this is the tertiary. Okay, so this is the chemical reaction. If we talk about the mechanism, then the nucleophilic substitution reaction perform two type of mechanism. Okay, perform two type of mechanism, which is known as SN1 mechanism and SN2 mechanism. Okay, SN1 mechanism and SN2 mechanism. SN1 mechanism and SN2 mechanism. Okay, so what is the full form of the SN1 mechanism and SN2 mechanism? SN1 mechanism is stand for the unimolecular unimolecular nucleophilic substitution reaction mechanism. Okay, and this is the stand for the bimolecular nucleophilic substitution reaction mechanism. Okay, mechanism. So SN1. Okay, first we talk about the SN1. SN1. What is the SN1? Okay, SN1 unimolecular. Why this is called the unimolecular? So the SN1 reactions in the rate determining step. Okay, rate is equal to K active mass of Rx. What is the mean of this? The mean of this that in the rate equation only one molecule is present, or you can say that the rate of the chemical reaction depends only on the one molecule, which is the alkyl halides. So this is called the unimolecular. Okay. In the second condition, okay, this mechanism completed in two steps. Okay, two steps. And first step is slowest step known as rate determining step. Just wait, I just perform this chemical reaction here. Okay. Okay, determining step. In the second step, just one minute, one point to forget it. In this step, formation of carbocations intermediates takes place. Okay, so this all performed in the first step. Now we talk about the second step. In the second step, attack of nucleophile takes place to the formation of product. Okay, so this is the basics of the SN1 reaction. Okay, so this is the basics of the SN1 reaction. This reaction complete into two steps. One step is the rate determining step, slowest step, and in the first step, formation of carbocations intermediates takes place. Okay, carbocation intermediates formation is the key of the unimolecular substitution reaction. Okay, unimolecular substitution reaction stand identified by the formation of intermediate. This is the stable intermediate carbocation. What is the meaning of carbocation? When the carbon consume a positive charge, then it is called the carbocations. Okay, and it can also be primary, secondary, and tertiary. Okay, and the most stable carbocations, when if we talk about the feasibility of the chemical reactions by the mechanism of SN1, then we talk about the stability of the carbocations. Okay, stability of the carbocations. Those molecules are feasible for the SN1 reaction mechanism which form a stable carbocations. Like if we talk about the tertiary carbocation, secondary carbocation, tertiary carbocations, and secondary carbocations, and the primary carbocations, then the tertiary carbocations is more stable than the secondary carbocation and the primary carbocation. Is that clear that all the compounds which can form tertiary carbocations are performed by the SN1 reaction mechanism. Okay, I hope it can be clear. It may be clear to you that how to SN1 reaction perform. Now we perform. I go to perform. What is the SN1? SN1 step first. Step first. In step first, breakdown of Br from the carbon takes place. Okay, and the pair of electron go to the Br. Why? Because Br is a more electronegative, and this is the slow step, and this is the also a reversible step. What is the mean of reversibility? That product can be converted into the reactant. Okay, so here formation of CH3 and CH3 plus this is the carbocation and this is the Br minus. Okay, Br minus. So this is called the tertiary tert butyl carbo cation. Okay, cation. Now we go for the second step. Step second. What is the step second? The formed carbocations in the first step get attacked by nucleophile OH minus ion. Okay, and then this is the first step. Then the formation of CH3 and CH3 OH. Okay, OH. This is the product. Okay, so this is about the SN1. Okay, now we talk about the SN2 reaction mechanism. What is the SN2 reaction mechanism? Due to the lack of time, I just explaining all the very fast. So don't mind, please. Okay, SN2. SN2 stands for the bimolecular nucleophilic substitution reaction. So bimolecular means two molecules. Means rate is equal to K active mass of Rx along with active mass of nucleophile. Okay, active mass of Rx along with the active mass of nucleophile. Means the rate of reaction depends on the both of the molecule. What both of the molecule? Concentration. Okay, concentration. This is depend on the concentration of the molecule, both of the molecule. Okay, SN2 name is SN2, but completed only in one step. Okay, only in one step. And the formation of transition state. The formation of transition state, TS, short TS, takes place. What is the transition state? A state in which bond formation and bond making, okay, bond breaking and bond making takes place simultaneously. This is called the TS, a transition state. Okay. For the SN2, we can perform the reaction. With a primary carbon, like this. Okay, like this primary carbon Br. So the nucleophile OH minus react on the carbon from the back side, because in the starting I was discussed about that Br is a more electronegative and the carbon is less electronegative. So Br attract the lone pair of electron, so it get negatively charged partially, partially negatively charged and it get partially positive charge. So due to the presence of partial positive charge, OH minus can be attacked on the carbon. Okay, so after this, hydrogen and hydrogen, after this, breaking of the Br bond and the making of the OH bond occur simultaneously. So this step is called the transition state. Okay, and this is the unstable state which cannot extracted from the isolated from the chemical reaction. Unstable. Okay, unstable. So this is the bond breaking, and this is the bond making. After this, what happened? CH, H, and OH. You can see that one thing here. What? You can see that one thing here, that Br presence on the right hand side and the OH here located on the left hand side. So inversion in the configuration occurred in the SN2 reaction mechanism. Okay, inversion in the configuration occurred in the SN2 reaction mechanism. If we talk about the SN1 reaction mechanism again, then if the SN1 reaction mechanism is started with a optically active compound, then the formation of a partial racemic mixture takes place. Why the formation of partial racemic mixture takes place, not the complete racemic mixture? Because there are possibility that formation of some amount of opposite attack or backside attack possibilities. Okay, but not surety that 50% of the compound can be formed. Okay, so this is the due to this reason formation of a racemic mixture takes place, but in the partial condition, not the whole condition. Okay, not the complete. Okay, not the complete mixture, but in the partial condition. So this all about the nucleophilic substitution reaction and the SN1 SN2 reaction mechanism. I hope some concept may be clear for you. For today, this is sufficient. Okay, thank you so much. Bye bye.